Welcome back to OK Calculus. Last time we explored the rules of continuity and how to find asymptotes. Today's topic is our first dive into one of the most important subjects of calculus, derivatives. Derivatives are the slope of the line that is tangent to a function. What does that mean? A tangent line is a line that hits a curve at only one point. Finding the slope of that line is our goal. Fortunately, we have mathematical ways of finding the slope without having to estimate. Take the function f of x equals 2x for example. To find the derivative, you find the slope of the tangent line. Luckily, the slope, found using rise over run, everywhere is 2. So the derivative of f of x graph would be a line at y equals 2. We run into a problem with curvy graphs like x squared or x cubed, however. The slope of the tangent line is always changing, which makes it impossible to sit there and estimate the slope of those tangent lines forever. There are very simple proven methods to find the derivative functions of these curvy graphs. The first being the power rule. The power rule states that if you can bring the exponent out front and then subtract 1 from the exponent. For example, with x cubed, you would bring the 3 out front in the exponent and then drop the exponent by 1, which leaves you with a 2 in the exponent. Doing this process will give you 3x squared. This is a function all on its own now. Since we took the derivative of its original function, f of x equals x cubed, we will call this the derivative function f prime of x equals 3x squared. Every time you take a derivative of a function, you must put another apostrophe in front of the f to show that it is a derivative function. Understanding what f prime of x equals 3x squared means is even more important than how to find it. Like mentioned before, this function shows the slope of the tangent lines to f of x equals x cubed. So if I were to ask you what the slope of the tangent line was of f of x equals x cubed at x equals 2, you would simply plug in a 2 into f prime of x, which will give you a 12. Let's think about this for a moment. This may all sound kind of useless to use, but it does contain some real-world applications. For example, taking the derivative of a person's position will give you their velocity, and if you take the derivative of their velocity, you will get their acceleration. We will also use derivative functions to determine rates of change in volume, area, and surface area. With the meaning of derivatives in mind, there are many more rules and techniques of how to find them. So far we've learned the power rule, but let's practice a couple more examples to get it down better. The first problem asks us to find f prime of x when f of x equals 3x to the fourth. Like I mentioned before, the apostrophe means the derivative function of f of x. You should then launch into the power rule once you see that exponent of 4. First, we'll bring out the 4 in front and multiply it with the 3 to get a 12 out front. Then you drop the 4 down to get a 3 in the exponent. And that'll get you to f prime of x equals 12x cubed. Let's go to the next problem. It asks us to find f prime of x when f of x equals 2x plus 1. For this one, treat the 1 as if it's being multiplied by x to the 0, because anything to the 0 power is 1. Once you treat the 1 like that, you would bring the 0 out front, which would be 1 times 0, which equals 0. Finally, the 2x would turn into a 2, because bringing the 1 out front from the x to the 1 power would drop the exponent to 0, and x to the 0 is 1, leaving you with 2. This means that f prime of x equals 2. One thing I must mention is that when you're taking the derivative of two numbers being added together like 2x plus 1, you can simply take the derivative of the 2x and the 1 and add them. However, when you see something like x plus 1 divided by x minus 2, you can't take the derivative of the top and then divide it by the derivative of the bottom. Same goes for multiplication. The derivative of the product of two quantities does not equal the product of those two quantities' derivatives. There is a rule to take the derivative of quotients and products. Let's start with the derivative rule for products. This is the general formula for the product rule. What this means is that you take the first quantity multiplied by the derivative of the second quantity, and then add the second quantity times the derivative of the first quantity. A simple mnemonic device to remember this would be first d second plus second d first, where the d stands for the derivative. Let's practice the product rule by finding the derivative of f of x equals the quantity x squared plus 2 times the quantity 2x squared plus 4x. Just follow the saying I taught you. take the first quantity, which is x squared plus 2, and multiply it with the derivative of the second quantity. Using the power rule we learned previously, you'll get 4x plus 4 as a derivative of the second quantity. Next, add the quantity x squared plus 2 times the quantity 4x plus 4 to the product of the second quantity times the derivative of the first quantity. The derivative of the first quantity is 2x using the power rule also. Finally, add the two products together to get f of prime equaling the quantity x squared plus 2 times the quantity 4x plus 4 plus the quantity 2x squared plus 4x times the quantity of 2x. We could simplify this down by using the FOIL technique, but I will leave it for now. Since the next two rules are a bit more complex, I'm going to split this lesson into two parts. Next time, we will explore the quotient rule and the chain rule. Thanks for watching.